Okay, so this unit is called the unit circle. And we basically learned two things yesterday. We learned that you can convert an angle between radians and degrees. So we also learned this equality, pi radians is the same as 180 degrees. Okay. So we use that if I want to convert 40 degrees to radians. All I do is I'm either going to be multiplying by pi over 180 or 180 over pi. In this case, because I'm going to radians, I'm going to multiply by pi over 180. So this type of conversion is really simple. More than 180 degrees, I guess. The degrees cancel out. So I end up with 40 pi over 180. That is the answer. Although usually in the answer key or the solution, it will be reduced. So here you can see the zeros cancel out. And I'm left with 4 over 18, which reduces to 2 over 9 pi. So you can write it like 2/9 pi, or you can write it as 2 pi over 9. Either one is fine, of course. Okay, that's how you convert from degrees to radians. Going in the other direction, from radians to degrees, if I have something like this, 7/10 pi, and I want to convert it to degrees, well, now I'm going to do exactly the opposite. 180 over pi, right? Which now leads to this, 7 times pi times 180 over 10 times pi. You can see here the pi's cancel out. The 10 cancels out the 0 here, and I have 7 times 18, which gives me 126 degrees. Right? Technically, I guess you should put a degrees here each time so that it stays with you and so that it cancels out. Right? Is that okay? And then we had the questions where we had used this formula. So this is converting. I'll give you a little header. Converting. So that's this part here. This is how you convert. And then we had, using this formula, S equals theta R. And we said that S is the arc length, theta is the angle, and R is the radius. So if they gave you a question like this, circle has a central angle of 30 degrees. It subtends an arc length of, I don't know, 6 centimeters. Find the radius. Makes sense. So we have, the thing here is the key that you should be looking at. The key that you should look at is right here when you see arc length. That should be your big clue that I'm using S equals R theta, right? Or theta R. Doesn't matter which order you write it. So S equals theta R, that's the one I'm using. It's a good idea sometimes to highlight key things in the question, right? Central angle there, arc length there. Okay, so I know the arc length is 6, and I know the central angle is 30 degrees. But that's the problem, right? This measurement has to be in radians. So theta must be in radians. So we got to convert first. So we've got 30 degrees going to radians, means that pi has to be on the top, right? Which reduces to pi over 6. So you can see the reduced part is beneficial when you're working with the formula, right? And that allows you to probably find the answer without having to use your calculator. So this is pi over 6. This is r. How do I solve for r now? Anybody know? Well, you could figure out what that number actually is, pi divided by 6. Okay, it's like 0.523 or something like that. You could try it in your calculator, but you can continue. Basically, we're solving for r, so what do we need to do? We need to get rid of the 6 and the pi, don't we? So we're going to get rid of the 6 by what? Multiplying it, right? So that gives me 36 equals pi r. And how do I get rid of the pi? Divide. So r would equal 36 over pi centimeters. And that's totally acceptable as an answer. Some of you feel more comfortable to actually divide it and come up with a number that will be a little bit over 10. Right? Maybe even, that would be 11, but not 12, I would think. 11.46. Okay, does that kind of make sense? So that's what we did yesterday. That's basically the big stuff you should remember from yesterday. Yes?
Okay, what if you have data in the radian and you have the radius? How do you find r?
You just, okay, so that's a good question. So if you have theta equals, what is it? 5 over 8 pi, and you have the radius equals 40. So S is what you're trying to find, right? So just substitute it into the formula where they belong. S we don't know. Theta is 5/8 pi. R is 40. So now it's just a matter of manipulating or calculating those numbers, right? Now, you can do this on your calculator for the question. I don't have the calculator up front, so in my mind, it's a bunch of fractions that I'm multiplying. Like that. And then the 40 divided by 8 is 5, so I end up with 25 pi, which will be 76 point something or something like that. 77 point something maybe. 78.5, okay. But if you're going to give the answer like this, you actually have to give it to 3 decimal places. Whereas I can just get like 25 pi centimeters and I don't have to figure it out. Does that make sense? Okay, so basically it is the same formula. Sometimes they'll give you these two, sometimes a different two. So you have to solve for the one that's left. That's yesterday. Okay with that? All right. So we're going to move on to today. Today we've got basically 3 concepts. One you're fairly familiar with. You should know this. And maybe this will be taught in different ways, but suppose there's an angle. Remember we're talking about things on the unit circle. If I drew an angle in standard position, you can see that the coordinates of this point would be x, y, right? Coordinates of that point would be x, y. And now if I talked about the sine of that angle, and if we call this r, because it's the radius, okay? What's sine again? SOHCAHTOA sine is, what is it? What's the ratio for sine? Opposite over hypotenuse, right? And in our diagram, the opposite side of theta would be y, wouldn't it? Right? It would be the height. So sine is going to be y over r. Did you do this last year and write them in terms of those letters? Or not? Because you don't have to. You can think of it as SOHCAHTOA, but I prefer to think of it as y and r right away. So that's new to you? Okay, so I'll spend some time. Let's look at that again. So this angle theta here, the opposite of this side would be y, right? And the adjacent side would be x. It would be how long it is here, right? I'll break it down. Here's my x, and here's my y value, right? Does that make sense? Okay, so sine would be opposite over hypotenuse, which is y over r. Cosine would be what? Adjacent over hypotenuse, which would be, in our case, what? X over r. Okay? And tangent would be opposite over adjacent, which is y over x, right? So I want you to think of it in terms of these, x, y, and r, instead of opposite and hypotenuse. Because that way, when you had the question like you did last year, like this, remember doing those type of questions? Where the arm would go through a particular point and you had to find the sine value, the cos value, and the tan value. Kind of familiar? Well, when you do that, I just want you to do this then. I want you to say, well, when we go through a point, it's the point x, y. Right? Whoops, wrote on r. I was thinking ahead to solving for r. It's the point x, y. Agreed? Every point has the coordinates x, y. Make sense? So cosine is x over r. So basically, I already know the x value is 5, right? I just need to find the r value. Well, how would I find the r value in this triangle? What would I do? Anybody know? Give you a little hint here. It's a right angle, so how could you find the long side? Pythagoras, a squared plus b squared equals c squared, right? So you're going to use that a lot today. So that means x squared plus y squared will equal r squared, right? We're looking for the longest side, so that means we add the squares that we know. Remember that? So it's going to be 5 squared plus negative 12 squared. Don't forget, when you square a number, it's always positive, right? Sometimes when you put, some of your calculators, when you push a negative 12 squared, it'll actually say negative 144. Most of the calculators now automatically put a bracket around it. But you should know that this is positive, right? So 25 plus 144. What do you end up doing at the end? Square rooting it, right? So r is going to be the square root of 169, which is 13. It's a lot of steps, but usually people get pretty fast at this. You just square both numbers, add them, take the square root, right, if you're looking for the longest side. So that's what you did last year, except that I'm writing it this way, right? Okay, so let's go a little further. I'll write these down again. Okay. We had a kind of, we came up with a pretty goofy mnemonic device to try to remember these things. You certainly can do this. if you're not into goofy mnemonic devices, just write your theta here, put your y there, and your x there, and your r there, and you should be able to come up with these ratios, right? Our mnemonic device was, say you're really cute. Say, you're really cute. X-rated. Thank you. Excellent. So if you can remember that stupid phrase, say, you're really cute. X-rated. Thank you. Excellent. So you remember that mnemonic device that can help you to remember maybe how to come up with these ratios, okay? We're going to work with them so much that it's probably going to come pretty easily. You do know that R will always go on the bottom because it's the hypotenuse. And the other thing that maybe you can just have to do then to remind yourself is that sine is connected to y, cos is connected to x. And the rest become kind of self-evident. Tan is always sine divided by cos, so it's y over x. I don't have to think of it that way. You can see it y over x. It's right there. So whatever you do, you're going to have to memorize that somewhere, okay? All right, here's something new. So that was from last year, except that I kind of put a little different twist on it. Here's the new part. These things have different names. There are actually 6 trigonometric ratios. There's also a name for when you take r and divide it by y. There's also a name that we give for r divided by x, and for x divided by y. Okay, so we have different names. Just like in baseball, you got lots of different names for different things. Your batting averages, hits divided by at-bats. Your slugging averages, bases divided by at-bats, right? So it's all kinds of different ratios. We give them different names. So I'll show you what they are. Some of them make sense, some of them don't. It makes sense that if tan is x divided by, or y divided by x, cotan would be x divided by y. So this is tan, cotan. So that's pretty easy to remember that they're connected. The other two are kind of goofier. Sine, the reciprocal of sine, reciprocal is when you flip them around, right? You heard that word before? Reciprocal. Flipping the numerator and the denominator around. So the reciprocal of sine is cosecant. So it's r over y. And the reciprocal of cosine is secant, which is r over x. Now, if I had made these up at the beginning, I could have made this a lot easier to remember. But unfortunately, I didn't make these things up. And I'm guessing that these particular names have to do with certain properties of the circle, and so, because secant is part of a circle, so I'm not going to change any names. So anyway, that's what you got to connect. The way that I remember this is cotan is a flip of tan, and in the other cases, you have to go to the opposite letter. The S goes with the C goes with the S. So you don't go with the same letter, you go with the opposite letter. Fine, it's reciprocal. Does that make sense? That's the way I kind of remember it. Okay? Don't panic too much about memorizing it today. Hopefully by the end of today, it'll probably be in your memory bank a little bit better. But by some point, you'll have to have it memorized. So, this is now how a typical question would go. So here's how this question goes. So it's a pretty straightforward question. And what you're going to be using is this information right here. So hopefully you have written down sort of someplace where it's accessible. So if cosine theta equals 15 over 17 in quadrant 2, find cosecant theta. Well, cosine is what? Right here, right? X over r. So when I'm I'm solving this, that means this must be x and this must be r. Do you agree? I'm asking you for cosecant. What's cosecant? R over y. Right? You follow that? This is the way all of these questions are going to work. I call them x, y, and r questions. They're basically following the same procedure every time. They give you two of them. You got to find the third one by using Pythagoras, and then you got to fill in the ratio that they ask for. So it's a pretty standard kind of procedure. Let's see how it works. Well, I know that x is 15, y I don't know, r equals 17. So now in this case, I am looking for one of the smaller sides. Do you agree? I've been given the radius, so I've been given the hypotenuse. So I'm not going to write down the whole formula. I'm going to, well, I could do this. I could say 15 squared plus y squared equals 17 squared. That's true. But I would go straight to this. Y is going to be the square root of 17 squared take away 15 squared. Right? If I'm trying to find one of the smaller sides, then I'm going to have to subtract the squares. Do you get that? So that's 289 take away 225, which is 64. Y equals 8. Okay? Now, here's the thing you don't know. You don't know whether this 8 could be a positive 8 or a negative 8. Because technically you're solving for y squared equals 64. That means it could be positive 8 or negative 8. Does that make sense to you? So here's what you've got to do. Here's the second part. So the first part is, I guess you would write the x, y's, and r's. Then you would use Pythagoras. Okay, so now I would actually have this. Cosecant theta equals r over 8. 17 over 8. Got that? That's pretty close to the right answer, but it might not be the right answer. Okay? Oh, you know what? I did something wrong here. Make that in quadrant 4. Okay? Scribble that up and put a 4 there. It can't be in quadrant 2, so. Got that? Quadrant 4. All right, now here's the thing. The third part is to use, well, quadrants, but you will remember it like this. You remember seeing this? What do those things mean? Do you remember?
First one's all of them.
Uh-huh.
All fall into. Second one is sine, and then tan.
Good. That's true. That's what those letters stand for. I agree. That's good. And when they say all, what do they mean? Right. These are the quadrants where those have positive values, right? In other words, if I took the sine of an angle between 90 and 180, it would give me a positive value. But if I took the sine of an angle between 180 and 270, it would produce a negative value. Only tan values would be positive there, right? You get that? No? Good. Okay. This is a really important thing, so I'm going to say it again and see if we can figure this out. This represents, you know our trig ratios? Later, like sine, cos, or tan. If you would take the sine, cos, or tan of any angle between 0 and 90, like the tan of 30, or the sine of 50, or the cosine of 70, they would all have positive values. Okay? Try it. Do you got a calculator in front of you? Okay. If you press the sine of 120, it's a positive value. if you press the cosine of 120, you will get a negative value, right? So here, up here, in angles up here, it's only positive for sine. Is that still kind of iffy? Here's what you do. So that's good to know, but here's what you do. We're in quadrant 4, right? We're in this quadrant where cos values are positive. That was true in our question, right? Our cos value was positive. That's why I had to change it, because I made a mistake. I wasn't thinking ahead. So the cos value is positive. If we're in quadrant 4, only cos or secant, because it's connected to cos, right? Secant would just be the flip, wouldn't it? Do you get that? We said before that secant was the flip of cos, the reciprocal. So it will also be positive there, because all you're doing is flipping around the numbers. So that means this is cosecant. It's not a cosine function. Cosecant is connected to sine. So therefore, it must be negative in here. So we have to add a negative sign. So the last step is we use the quadrants to determine whether we're going to be leaving it a positive or making it negative. Okay? I guess you can guess, but here's the other thing. It also makes sense if you think about it this way. Maybe this will help you. Some of you can think of it this way. When I solve for y here, right? That's what I solve for. Well, if you think about y in quadrant 4, what's the y value going to be in quadrant 4? It has to be negative because it's below, right? I'm down here somewhere. The y value would have to be negative. So some people do it that way. They look at the quadrant and use it to determine whether that y value would be negative or positive. That makes sense? The x value would be positive because I'm to the right. Makes sense? So you can use it that way, or you can just look at the chart. Let's do another question. Okay, let's follow the steps. Number 1. Put it here. So number 1, we're gonna, maybe label is a better word. I think label is better. I like that better. So if I've given you sine, what have I given you? Which values have I given you? Yes? Y and R. Did I get that right? Lisa and Christine? All right. So that's y and r. Tan is what? Y and x. So that's good. Number 2 is to do what? Yeah, Pythagoras. I can make my little chart here if I want. I sometimes do that. I know that this is -7. I know this is 25. Right? So, which one am I looking for? X, obviously, is what I'm missing. What am I going to do with the squares? Subtract or add? Subtract, because I've got the biggest one, don't I? $25 squared is 625. Subtract 49 is 576. And I get 24. Okay? Is that okay? But again, we don't know whether this 24 is positive or negative.
So you do that thing where you put this positive and negative sign beside it, or you use...
Yeah, you could do it that way. It's okay to just leave it as 24 and just recognize that I need a third step, right? So now I need to use the quadrant to decide whether it's positive or negative. And like I said, there's two ways that you can do this. You can think of quadrant 3 down here, right? You can think of tan, right? So, two ways to do this. One way to think of is that if I'm in quadrant 3 and I'm solving for x, what's the x going to be? In quadrant 3, what's the x going to be? Negative. So I could put a negative 24 there. Right? And then my answer would be negative 7 over negative 24. You agree? Which is really positive, isn't it? Is that okay? Now, the other way that I could have done that is I could have said, oh, well, I'm in quadrant 3. I know that tan is y over x. So I know the numbers are 7 and 24, right? Oh, but I'm in quadrant 3, so tan is positive, so I'm just going to leave it like this.
That's what I would have done.
Yeah, that's kind of it's a nice way to check it right at the end. But both would have got us the right answer.
Well, would it work every time to do it like that?
Yeah, it works every time to do it. This way works every time. This way sometimes things can get a little tricky. But that final check is always 100%. Okay, are you kind of getting it? I see a few more people seeing like they have a better grasp of it. Let's look at another one. You can see that I'm going to not get through my whole lesson today, so I'm going to do this here. Okay, last one of this type. Suppose I give you this. Tan theta equals 12 over 5 in quadrant 3. Find secant theta. Label x, y, and r. Okay. This is y. This is x. Right. Oops. Yeah, that's right. Number 2, Pythagoras. What are we going to do this time to the squares? Add them, right? So 5 squared is 25, 12 squared, 144. It's 169. After a while, you're going to start to recognize these numbers, right? Because there are a limited number of perfect squares that kind of work out in numbers that we work with. So it doesn't have to be a perfect square, but we will want it to be in these type of questions. Okay. So now we're supposed to find secant theta. Secant is r over x. And we're in quadrant 3. Agree? Oh, and by the way, when you solve for r, it's always positive. So that part is a little easier. R will always be positive.
Just x will be negative?
Well, that's just it. Now we're not sure. That's good. You're thinking that x is negative. Yeah. Because why?
It's quadrant 3.
Excellent. We're in quadrant 3, so the x is going to be negative, even though it looked positive at the beginning. Now, it kind of makes sense if you think about it, because this is just what happened in the previous question, right? We had 2 negatives, and they canceled out, right? So technically, now you don't have to need to know this. Look at this, though. Technically, both of these numbers would have been negative, right? Because they were in quadrant 3. But really, you can use this method and say secant theta equals r over x, 13 over 5. But I'm in quadrant 3. Secant is not a tan function, right? So therefore, this must be negative.
The whole thing is negative?
The whole thing is negative. Well, technically, the 5 would be the negative part, but it doesn't matter where you put the negative sign. That's important too. Did you hear that? It doesn't matter where you put this negative sign. It just has to show that this value is negative somewhere. Is that good? Okay, I see a few more lights going on. I'll give you one last question. Simplifying an expression. Suppose I ask you to do this. I ask you to simplify cosecant theta by cotan theta. This is how you do it. Substitute x, y, and r. So we change these things into reading x, y, and r. Cosecant is, on your chart, r over y. Cotan is x over y. How do you divide fractions? Remember what you do? Yeah, you flip and multiply. So it equals r over y times y over x, right? You got that? Which will now equal r over x. You get that? And which one is r over x? Secant theta, right? Yeah. So that's the right idea, though. Right? So, that one's just putting it in, changing r and x, flipping around. Here are the questions I'd like you to do today. So I'm not going to give you the whole assignment, because I saw in the beginning that we need a little bit more work with those quadrants, which is true almost every year when I do this. So you should do questions 1, 2, 3, 4, and 9. Okay? 1, 2, 3, 4, 9. Just those 5 questions. Does anybody need me to print out the notes? Okay? And yeah, I'll leave you with this example here, I guess. This is a good example here. I imagine most people got those ratios down, right? I like the one that had the steps on there. Where was it? This is a good one because it's got steps nicely. Oh, 1, 2, 3, 4, and then 9. So 1 to 4 and then 9. Okay, I'll go get the notes and I'll be right back. press print. Good question. Anybody have questions? Okay, sorry. I was going to give one example like that. What's the first question? It says, what's your value?
Cos theta equals 8/17.
Right. That's what I was going to do. Okay, class, look here. The first question tells you the quadrant, but not specifically. All my questions said which quadrant it's in. This one doesn't tell you explicitly what it is. But it tells you that it's in the quadrant where cos is positive, right? Because it's a positive value. Right? So it's got to be in this one or this one. Agreed? But it's also in the quadrant where tan is negative. So that means it has to be in quadrant 4. Right? Because tan's positive up here. Tan is negative here, or here and here, right? So this is a quadrant that meets both those conditions. Right? Should I say that again?
Yeah.
Okay. So the question states the value for cosine, which tells you that cosine is positive. So that means that angle would have to be in 1 or 4. Those are the only quadrants where cosine is positive. But then it also tells you that it's in the quadrant where tan is negative. Right? So out of those two, quadrant 4 is the, 2 and 4 would be for tan, but the only one that meets both those conditions is right here. Does that make sense? So you just use a little cross.
The answer will be negative.
What's the question for? It means that we're in quadrant 4. So if I'm solving for a cosine function, it'll be positive, but if I'm solving for anything other than a cosine function, what is it asking you for?
Asking for
Sine would be negative here, tan would be negative here. Okay? Good. Anybody else want notes?
Yeah, sure. I did one off.
instead of writing negative sign.
Now we're gonna have to use the quadrant to consolidate these things. So I'm going to positive and cosine is positive. Maybe forward constants apart. But also in the R. So only cosine functions are positive so far. Everything else is negative. Okay? Makes sense? Any questions anywhere? Oh, you got this one. You got these ratios. Where do you get your ratios from? Oh, you labeled the sides wrong. That's what it is. So for now, just keep this little chart right here. Like refer that. So you labeled, I think you did everything right. So this is an X. So you got your X and Y mixed around. So this should be you got this right. Okay. So yeah, this should be 15 over 17. That's actually okay. This should be Y over it should be maybe mixed up a couple of things. I ended up getting it right somehow. Yeah, here just said Y over X. That would be 15 over 8. So that's fine. Yeah, that's right. Okay. Anyway, so now you've done that. So step one is to label, right? X, Y, and R. And you can do it here, and you can do it here. Step two is to use this. And then step three is to label the ratios positive or negative by the quadrants. Okay. So you're in the quadrant where cos is positive and tan is negative. That puts you over here. Do you get that? So I'm in this quadrant, which is C. So only cosine functions are positive over here. That's not a cosine function. Yeah. You just put it. Technically, you can figure out which number here. It's not going to be R, but you just have to put a negative in front.
So I'm not trying to figure out which number.
No. All right. Good. Yeah. Well, you got it mixed up with your actual number, but you got the right. Okay. Questions anywhere? Oh yeah. That for number 3. When you get the square root of 24, just leave it as square root of 24. Because technically we're asking for an exact value, so you don't round it off. And you won't be able to use the calculator in this section, so. Well, the numbers will be smaller ones. They won't have numbers like 24 in there. It'll be numbers, the biggest they'll get is 5, 12, and 13. Yeah, those are pretty simple.
Okay, R is only positive, right?
Yes.
Okay.
Well, I don't know, like
What's 24 squared?
576. But I made some of the numbers so big that you would use calculator. But don't actually press the square root button. That's what I'm saying. Like, oh yeah, I don't get it. What are you guys doing there? Good? You Oh, not the famous then. See, that's why I don't give people credit for these actions. Well, one of the this is good. Cosine is x over. Well, you had I'm trying to see if I can get my picture taken. Okay. Oh, I pressed the wrong thing. Got it. There we go. Full screen. Hey, class. Did you get those pictures taken already? No, not all of you. How many people have not had their pictures taken yet? Any? Mine was too long. I don't care. They got lots of pictures to take. They can just recycle one from the year before. All right. Here's some questions of the day. What's the term for arable land left unseeded for one season? What's the term for arable land, which means is useful land, that's left unseeded for one season? What's that? Well, that would be sterile. Yeah, sterile land. But this is when farmers deliberately leave a land unseeded to rotate and get it to replenish itself. It's called summer, and then this word. We call it summer fallow. It's called fallow. There you go. You learned something about farming today. Who is considered the patron? Who is considered the patron saint of children? Saint Nicholas. Saint Nicholas is right. Or Michelle. Either one's right. What animals does a hippophobe fear? That's what you would think. But no.
Dog, cat, lobster, fish.
Hippophobe. It's
Giraffe.
it's actually horses.
Oh, I didn't know that.
Because the hippodrome is where you have horse races. I don't know if you remember that from the Greek days when you were back there in Greece. I was. It's one of those trick questions. It's the same thing about the Canary Islands. You know which animal the Canary Islands are named after?
Dog.
A dog. Very good, because it's a canine. Yeah, you would get a candy if I had them today, if I ever remembered to bring them.
Write it down.
Write it down. Somebody call me tomorrow morning at 8:15. Bring the candy. I better bring it, because it's chocolate. And if I leave chocolate at home too long, alone with my wife, they disappear. Let me see if you know this one. Anybody know what Dennis the Menace's last name is?
Oh. I know it.
Yeah, we've heard that enough times in our lives.
Mitchell.
Mitchell! Yeah, good. Yeah. Okay, last thing. What is the strongest muscle in the body? Tongue.
I knew that one.
That would be true in symbolically too, right? The mouth is what has the most power, right? I think that's yours. Okay, so we will move on to lesson 2 today then. Oh, I should do a little bit of a quick attendance thing here. Spin. Sheet. Here's your sheet. Are you on the, did you just get registered or what?
Yeah, I did like really.
Okay. Okay, give me a yes if you're here. Riley, Callie, Trisha, Tristan, Megan, Brittany, Carrie, Dennis, Jenica, Shannon, Michelle,
Yes.
Sydney,
Yeah.
Skylar,
Yeah.
Dylan, Gina, Hayden. Hayden here? Okay, Lawson, Marina, Dana, Jaden, Travis, Kristen, Sierra, Jada, Greg, Rebecca, you're on the list. Brandy, Matthew, Gabby. Okay, we're all here. Beautiful. B-E-A, beautiful. Who always says that? B-E-A, beautiful. What? Bruce Almighty. Yes, Jim Carrey always says that. There's some good parts in it. Okay, so yesterday. Wow, this is weird without anything. I don't want the full screen actually. Yeah, got it on mine. Uh-oh. This is when I was going to press recording. I went, hey, that reminds me, I never stopped it from the last class. Yeah,
Oh my goodness. Oh.